Alright, we're being asked to solve this quadratic equation using the completing the square method. This is slightly more difficult because this lead coefficient here is not 1. And we'll take care of that in 1 second. The first thing I'm going to do, as I always do, I'm going to subtract away the constant coefficient to the other side of the equation. So I get 4w, this should be squared, plus w equals negative 4. And then what I'm going to do is take care of this lead coefficient by dividing everything by 4. And what I'll get here is w squared plus 1/4 w equals negative 1. Alright, now I'm going to complete the square. To complete the square, what I do is I take half of this b value. For fractions, you simply just multiply the denominator by 2. So 1/8 is half of 1/4, and then I'm going to square that result. And what I'm going to do with that is I'm going to add that to both sides of the equation. And so that will look like this. I'm going to add 1/64 to both sides. Okay, and this is where completing the square really gets pretty technical. The game here is now this side on the left that I've created. This will now factor into w plus 1/8. The number that's always used here is the same number that you had before you squared it. That's an important thing to note when doing this, especially with difficult ones like this. And then I just need to add these fractions over on the right hand side. Negative 1 is negative 64 over 64. And so what I get over there altogether is negative 63/64. Okay, so now what I'm going to do is I'm going to square root both sides of this equation, and on the left hand side what I get here, is w plus 1/8 equals, and I get a plus and minus over here, the square root of negative 63 over 64. And what I need to do now is take care of this radical side. I'll do this somewhat quickly, but the game is I apply the square root to both the top and the bottom. On the bottom, that's easy. The square root of 64 is just 8. On top, just quick to this note, I'm thinking of this as the negative 1 times 9 times 7. It's a square root of that. The negative 1 comes out as an I. The 9 comes out as a 3 when I square root it. And the 7 is left underneath the radical. Again, that move really on the top is just reducing the radicals with imaginary numbers being involved. Alright, so the final steps here, I'm just going to solve for w by subtracting 1/8 from both sides. Alright, and for that, what I would get is w equals negative 1/8 plus or minus 3i square root 7 over 8. And then you can combine those because the denominators are the same. So the final kind of condensed version of this would be 1 plus or minus 3i squared to 7 all over 8. And that would be our final answer for that problem.